This video is about surds. A surd is a root of the whole number that has an irrational value, and such a root cannot be expressed as a fraction or as a recurring decimal. For example, root 2. It cannot be expressed as a fraction or as a recurring decimal. Let's look at the rules of surds. If we have root s times r, root r times s, right? We can write it as root r times root s. For example, 8. 8 can be written as 4 times 2. So we can write root 8 as root 4 times root 2. So we get to root 2. Right. Next we have the square root of r over s, which can be written as root r divided by root s. For example, the root of 21 out of 3 is equal to the root of 21 divided by the root of 3. The root of 21 can be written as the root of 7 times 3. So we have root 7 times root 3 divided by root 3. So we get root 7. Number 3, r divided by root s. We can write it this way. We multiply the numerator and the denominator by root s. So we get r root s divided by root s times root s. So you get r root s divided by root s squared, which is s. For example, 3 divided by root 2 is equal to, we multiply the numerator by root 2 and the denominator by root 2. So we get 3 root 2 divided by root 2 times root 2. So we get 3 root 2 divided by root 2 squared, which is 2. Then we have b root r plus or minus q root r. So what we do here, we factorize. We factorize, so that is b plus or minus q times root r. Because root r is common here and is common there. So you can easily factorize, and we say that it is root r into p plus or minus q. Right, for example, we have 2 root 2 plus 3 root 2. Root 2 is common here, so we can factorize, and we have root 2 into 3 plus 2, or 5 root 2. Next is this expression here, r divided by p plus root q squared. So here we find the conjugate of p plus root q squared, and then multiply the numerator and the denominator by that conjugate. So we have the conjugate of p plus q squared root q squared is equal to p minus root q squared. So that is, we multiply r times p minus root q squared divided by p plus root q squared times its conjugate. Right. Now this term this one is actually a difference of squares. A squared minus b squared is equal to a plus b into a minus b. This is an algebraic identity which is expanded like this. A squared minus b squared is equal to a plus b into a minus b. So this term here can be compared to this term here. So to evaluate this term, we can use the difference of squares. We have the numerator is r into p minus q squared divided by this one is p squared. Comparing to this one is p squared minus this term squared. So root q squared is equal to q. Alright, so you get this as the answer. divided by 1 plus 2 root 3. This is equal to, we multiply the numerator and the denominator by the conjugate of 1 plus 2 root 3. This is equal to 1 minus 2 root 3. So we have 8 into 1 minus 2 root 3 divided by this. So you get, this one is a difference of squares. So we have 8 into 8 times 1 is 8. 8 times 2 is 16 root 3. Alright? Divide by 1 squared minus this 1 squared, which is 4. 2 squared times 2, 3 squared, you get 4 times 3 is 12. So it is 1 minus 12, you get minus 11. That's the answer. Now we have this exercise. We are going to rationalize the denominator. So here we shall multiply both the numerator and denominator by the conjugate of this 4 plus 2, which is 4 minus 2. That is 3 into 4 minus 2 divided by 4 plus 2 times 4 minus 2. This one here is a difference of squares. So we have 4 squared is 16 minus this term squared, which is 2. So we get here 14. And that one becomes 3 times 4 is 12 minus 3 times root 2. We get 12 minus 3 root 2 divided by 14 as the answer. Next, we are supposed to simplify this expression and leave the answer in the form a plus b root c, where a, b, and c are integers. So we have 3 root 5 divided by 7 minus 3 root 5. So you can multiply both the numerator and denominator by the conjugate of 3 plus root 5, which is equal to 3 minus root 5. So you have 3 plus root 5 times 3 minus root 5 divided by 7 minus 3 root 5 into 3 minus root 5. Right? So the upper part is a difference of squares. So you get 3 times 3 is 9 minus this term squared is 5. Root 5 squared is 5. So you get 9 minus 5 is 4. And the lower one, you multiply this by this, you get 7 times 3 is 21. This term times this one plus this term times this one, you get 16 root 5. Okay? Because 3 times 3, you get 3 times minus 3, you get minus 9 root 5. And then this one is 7 times minus root 5, you get that one. So you get 9 plus 7 is 16 root 5. Then plus this term squared. This times this, of course, this term that is this term. So you get minus 3 root 5 times minus root 5. So you get root 5 times root 5 is actually 5. 5 times 3 is 15. And because the sign is negative here and here, you get a plus. So that's how we expand this term here. So you get 4 divided by 36 minus 16 root 5. Because 21 plus 15 is 36. Then you minus that. So when you are here, you find that you can divide everything by 4. So you get 4 divided by 4 is 1. 36 divided by 4 is 9. And this one divided by 4 is 4 root 5. So this is what you get. And from here, you can come to this step here. You can multiply both the numerator and denominator by the conjugate of 9 minus 4 root 5. So you get 1 times 9 plus 4 root 5 divided by this one here, 9 minus 4 root 5 times its conjugate, 9 plus 4 root 5. So you get the upper one is there the way it is, but this one is a difference of squares. 9 times 9 is 81, minus this term squared, which is equal to 16 times 5. You get 80. So you get 9 plus 4 root 5 divided by 1. That's the answer. That's how you can simplify surds using those rules that we have learned. If you find this helpful, kindly subscribe to my channel so that you can support this work and so that you can view more videos.